Thank you. For those of you that were at the conference last year, I was here talking about the great things that we've been doing at Conoco Phillips around our digital twins. Happy to say that that whole program has now moved from what was an emerging digital technology to just how we do our business as an organization. So any new assets that we build, they have a digital twin built in by default. And that's just, part of how we work. As part of that, our management came back to me and said, okay, well, you've done a great job on digital twins. Now go figure out how we can do this for the rest of our business, which is 60% of our business, which doesn't have any of the source data that you actually need to build these things. So yeah, thanks for that challenge. Spoiler alert, how we're tackling this is digital reality, right? And this is OADT's perspective on why digital reality is so critical now, right? And it comes down to, these are Exxon's points, by the way, not mine, but we all 100% agree on this anyway, right? So the reality capture costs are going down dramatically. It doesn't care if it's mobile, terrestrial, drones, whatever, right? Those prices of those systems are going down. The cost of acquisition is going down. Accuracy is going up. I don't think people are aware that we're down to, millimeter level accuracy on some of these things, depending on the systems, which is pretty amazing. Maintaining the reality capture data is easy. You've seen lots of different examples today of how we're all storing that data in-house, taking that data in-house, and then distributing it through a content system so that everybody in the ecosystem can actually use that. And then we've got all these great software systems as well. OADT has really been accelerating this process. We've come up with these reality capture guidelines. Those are just a document that if you want to go and hire a scanning contractor, give them that document and say, this is what we want. It specifies the quality that you should get. It also specifies the standards of the data that we should get back, which means we can all use that in any of the systems that we actually want. Version 1 of this should be coming out very soon. We've all been working on that pretty hard, but that's a great deliverable for the group. Okay, so we talked a little bit about the challenge that was thrown to me, which was, okay, you've done a great job building these fantastic digital twins. This is digital twins classified in terms of a couple of accesses, capability versus source data quality. And it turns out if you've got great data quality, it's not hard to build these things, right? It takes time, it takes effort, but it's not hard. But the challenge that I've been given is, okay, down here in this area here where we've got these small assets, but thousands of them, how do you build a digital twin of that, right? And if you don't have that, you've probably all got, or a lot of the other operators certainly do have very old refineries where, again, we don't have much of that documentation. So they've got exactly the same problem as we do. It's just we've got it in a lot more scale. So with that, what I want to do is just take a look at two technologies, very simple things. Bear in mind that we're starting with a business now that doesn't really understand digital twins. They don't care about digital twins. How can we get them excited about a three-dimensional way of working? And so I'm just going to hit the play on this movie here. And we're heading off to Canada. This is Surmont. This is one of our assets in Canada. This is the well gathering area, basically, for our heavy oil assets here. And this is just using a consumer-grade 3D image capture tool. And the first point is right there, right? There is no bad angle on a 3D capture, right? So typically when people are taking photographs out on site, they end up as just a pile of files on disk. Here, everything is date stamped, time stamped, and available to you right away, right? So think about the use cases here, right? How many times do our operators have to go out to site just because some engineer wants some measurement somewhere, right? I mean, if you can, it doesn't take much to do that, right? We've just jumped from the outside to the inside. Now we're looking at a lot of the equipment in there. We've got a bunch of the valves there as well. In this one, we're kind of lucky. We do have the building information model, so we've brought that in as well. And again, that's information that typically is not in the hands of these types of operators, right? This is cloud-based technology, doesn't require a fancy PC. I simply just fire it up. Now I'm just clicking on that model, and I'm looking at the metadata that's associated with it, right? So again, just all really kinds of useful information, what type of valve it is, what its coordinate locations is, what the tag numbers are, all of that information, and it doesn't require any kind of specialized information or systems to actually do this. So very powerful just to be able to get this information in people's hands. And that's just some of the basics that are really kind of important to these. As well, we've got a lot of groups that are using this. Our capital projects love it for project documentation, right? So if you want to monitor progress, this is a great way to do that. Here we've got a split view that's going between those two views there, and you can look at different date stamps and compare the two, right? And then the last thing is this ability to be able to integrate both 2D and 3D together, right? But the key thing is that 2D is stored relative to the model, so you know where everything is all the time, right? This is just an example where we're just marking up some documentation here. I can add a description to it as well. We've just recently acquired Marathon Oil. I was up in Barkin just 2 weeks ago with our asset insurance group. This was engineers from all of Lower 48. We gave them one of these cameras, and by the end of the week, they were all experts on this, and they were incredibly excited about this. And this actually became the tool they're actually using for their assurance for these heritage marathon operation tools. So just very powerful, but very quick, very easy to do, and very cost effective. Of course, the next thing that's going to happen is like, well, I want to do some measurements off of that. Well, okay, so now at that point, we're down to digital reality here. And I'm going to take you on another different site here. This is actually the site. It's in the Eagleford. It's about 3 hours drive from Houston. There's all of our wellheads. This is our MSO, or boot camp training site. We have occasions where we can't get out to site because of weather, those kinds of things. We've had our operators, who are not necessarily the most tech savvy, actually teach their training class based on this technology. So just great savings there. And if we look at this, to acquire this particular data set, I actually did this acquisition. It was about an hour to go and acquire this data set. And you're looking at an X-ray image of that. You can see the millions to billions of points in the LiDAR data there. And if we look at this, we can move it around in a couple of different ways. The most important way is that we want to do this really quickly. So you can mesh those points and look at it as a surface, right? And if I can't stop this, but if I could stop this, I would make the point right here is that looks like an engineering design model, except it's reality capture. And then if you look at those individual assets there, if I could segment those assets, I've got a digital twin at that point, right? So that's what we're really shooting for here. Just some basics, guaranteed to get every engineer excited as soon as they see this. It's like, what do you mean? I can measure the pipe diameter? Sure, we can do that. The does it fit exercise? So can we push a piece of equipment through between two different assets? Yes, we can do that, right? So incredibly powerful just to be able to just look at this data. And bear in mind, like I say, it was 40 minutes to about an hour to acquire this. Simple ergonomic exercise here. Let's go ahead and look at everything below 6 feet. That's a problem if the valves are above 6 feet because people can't reach them. So just some simple things that you can do really quickly. Again, this is all just basic stuff that really gets our field staff excited about the technology. And then as well, we're fortunate in this case that we've actually got the LiDAR data for this, we've got the engineering design model for this. And what I will say is that this data set now has been 100% adopted by our in-house engineering design group. We have 20 guys that go do piping design. Here we're looking at the difference between our model and our LiDAR data. So this is right here. It's as model versus as design. If you look at these electrical panels here, you can see there was a change in the design between when they designed it, when they built it. If we look at the offtake pods here, you can see, again, that changed as well. So again, for the engineering group to be able to just very quickly do that visual analysis and then understand what's changed, that accelerates their whole design process as well. In fact, they like it so much they stole our LiDAR system, or we haven't seen it since, but they're going out and acquiring a whole bunch of data out in the field here. This is one of the things they really love, just this difference between my engineering design model and my reality capture here. So just great to be able to see that. So you can start to quantify the differences between those two. Useful things here, for instance, my CAD model has the subsurface pipelines. I can't capture that with reality capture, but straight away to be able to go and work backwards and forwards between those different data sets, this is really, really getting people excited. And obviously, basically the plan is get them hooked with this stuff, and then we'll start to figure out how to build a digital twin from that. So just to kind of finish up here, here's the vision for where we really want to go with this. Nothing unique here. I think lots of people in this room are actually probably ahead of us, but basically it starts with the GIS systems, being able to just pick on that GIS system, jump out to my three-dimensional world. I haven't had time to talk about this that much, but segmentation of that LiDAR effectively gives us that digital twin. We can connect to individual assets, connect to SAPs, connect to our documentation systems, real-time systems, and then enable all of those digital twin workflows, but without the cost, expense, and time of going through a full digital twin workflow. So that's my message. Thank you.